Hello everyone, welcome back to the channel. In the previous video, we deployed our Node.js application using Docker and configured Nginx as a reverse proxy. Now application should work if it has not stopped, but there's always a problem. If we stop our application and we want to start it, we have to type a long Docker command every time. So let's look at this scenario. So this is the IP address to my server. Right? And when I refresh, you see I get 502 bad gateway. Why? Because my containerized application isn't running again. So I'm not able to access it. So how would I start this application? What I need to do is to come to my terminal. Now I've logged into or SSH into my EC2 instance from this terminal. Now when I do docker ps, you realize that there's no, so let me do sudo docker ps. We don't have any container running. Okay, so to run this container, what do I need to do? I'll have to do docker run -d dash run in a detached mode, and then do my port mapping, which is port 3000, main map to the port 3000. Then I'll have to specify the name of my container, which I'm calling my app. Then I'll specify the image. So Node.js dash app version 1.0. Okay, so let's run this application. Okay, I need to bring sudo here because of some permissions. I'm going to do sudo. Okay, then end and then dash. Okay, so if I do docker ps now, I should see sudo docker ps. Okay, I should have my container running now. So I have my container ID, which is up 10 seconds ago. Okay, all right, so let's verify if my Dockerized application is up. So I need to refresh this here. Great, so we get hello from Docker, which indicates that my containerized application is running. Now, this is the issue. Imagine your application has 5 or 10 containers. Then it means that typing a separate command for each one would be difficult to manage. This means that anytime we want to start a containerized application, we need to run a command that is similar to the specifying the image. Okay, typing a separate command for each one would become difficult to manage, assuming we have 5 containers. So that is exactly why we are going to use Docker Compose. So in this video, you learn what Docker Compose is, why DevOps engineers use it, how to create a docker compose.yml file, and how to start and stop application with a single command. By the end of this video, you manage your application like a real DevOps engineer. Let's begin. So what is Docker Compose? Before writing any code, let's understand the problem that Docker Compose is solving. Now, supposing your application is written in Node.js, and then for the database you're using Postgres, then you have caching, and the caching you're using Redis, and then we decide to use Nginx as a reverse proxy or load balancer. Now we containerize all of this. So the Node.js is containerized, database is in a container. All of these things have been containerized. Without Docker Compose, I'll need to start every container manually. So I'll start my Node.js with my Docker run, do the same thing with the Postgres, move to the Redis, and then move to Nginx. You also have to remember the container names, the ports, their networks, volumes, and restart policies. Now, as the application grows, this becomes very difficult to manage. Okay, so to solve all of these problems, remembering the network, restart policy, volumes, ports, container names, etc., Docker Compose comes for you to start your application using a single command. So instead of remembering a lot of Docker commands, we'll describe our application in one YAML file. So let's think of Docker Compose as a project manager. Now, instead of telling every employee what to do individually, you give the manager one plan, and the manager coordinates everyone. So that's exactly what Docker Compose does. So in summary, Docker Compose is, let's say, an orchestration tool that is used for defining and running multiple container applications. So instead of running multiple complex Docker run, to start different parts of your application, you're going to configure everything in a single test file. And this file is your YAML file. Now that you've understood what Docker Compose is, which is a single file for starting multiple containerized application, let's verify that we are in the right directory to start using Docker Compose. So I'm going to run the command pwd, which is my print working directory. So I just do pwd enter, and then you see where I am. So I'm in a directory called Node.js Docker app. Okay, now let's verify that we have our files in this file. So I do ls enter, and then you see we have a Docker file from which we built our image. We have our application here. We have some Node.js models because it's a Node.js application. And then we have our package.json that contains our dependency. So everything is ready. Is ready. Now let's add Docker Compose. We've learned that we will need a file or a single YAML file where we are going to define all our multiple containers that we want to start. So we will need to create this file. So what I'm going to do is I'm going to do nano, and then the name of the file should be docker-compose.yml. I click on enter. Right, so now I'm in my editor. I'll need to paste some code here. Then I'm going to explain what each line of code means. Great. So I've copied some block of code into my text editor. So now let's understand what every section means. The first one we are going to look at is services. So every container is called a service. Now, for this YAML file, our application has one service, and that service is called app. Later, we can add different services to it. For example, we can have an Nginx service that's going to handle reverse proxy and load balancing for us. We can have a Postgres service that helps us to store, that's our database. And then we can have a Redis service that will set as our passion for us. And we're going to add all of these services to the same file. So the first one we have is services, and the first service we have here is our app. Now for this app services, or for this app service, let's see what we want to do. The next command after this is the build. So we have a build, and then we have a dot here. What that means is that look inside our current directory and then build an image using a Docker file. So when you do ls in this directory, you see a Docker file. Previously, that's what I showed you. So this command means that go and take this Docker file that is in this current image, and then look at all the instruction that has been defined in the Docker file, and then build an image from that Docker file. So that is the essence of this command: build a Docker file from the current image. The next one we are going to look at is the container name. So what this is doing is that it's going to give our container a friendly name. So instead of the random name that Docker is going to create, we are specifying the name that should be given to our container. So we are going to name our container Node.js -app. The next line is the port mapping. So we have two ports here. We have 3000 and another port 3000. Now this first port belongs to your server. That's our EC2 instance. And then the second port belongs to the container. So what it's saying is that map the server port 3000 to this port 3000 where our containerized application is running. The last command we are going to look at is the restart, which we set to unless stopped. So if the server restarts, what is going to happen is that Docker is automatically going to start our containerized application again. So anytime the server restarts, our containerized application is going to start again. And this is very useful, especially in a production environment. So now that you've understand how this so now that you've understand these lines of code, we are going to stop our old container, remove it, and then now use Docker Compose to create our own container. So let's save this file and I'll see you in the next session. So now I've stopped my container and I've removed it using the Docker remove by specifying the container name. Okay, now let's check something. If I do Docker images, I will should still see, let me do sudo, my previous image here. So even though I've stopped my container, remove my container, I still have my image. Why? Because by default, Docker Compose is going to reuse the existing local images. So it's not going to create a new one. That is why in the docker compose.yml, I have the docker.build. Let me just do cat docker. Um, okay. So you see here, build, and then I specify this current directory. So what is going to happen is that it's still going to pick this Docker file to build my image. So if it checks and then an image matching my configuration already exists locally, it's going to reuse that as image to create my container, even if the underlying code has changed, right? So when I am no longer using Docker, the Docker run, blah blah blah, to start my container. But when I use Docker Compose, because I'm building an image, I'm going to look at our current directory using the Docker file, and then if Docker checks that there already exists a local cached image. Okay, so it will not create a new image. It's just going to use the cached one to help start my container fast for me. So that is why I still have this image available even though my container has been stopped and then I've removed that container. All right, so how do we start the application? Now this is the exciting part. Instead of the long docker run command that I did, docker run -d port number name etc., what I will do is just use this command docker compose. Let me bring my sudo. So I'm going to do sudo docker compose, then I see app, and it runs in the background. So Docker is going to build the image, but this time around we already have an existing image. So it's going to use that existing image. It's going to create the container and then start the application all with one command. So let's do docker compose app -d and then let's click on enter. Okay, viewer. So I think I know why the Docker Compose app is not working as expected. So when I still run my Docker Compose, right, app, there's no command called Docker Compose. So if you're following along on, let's say, Ubuntu 2.4.0 earlier, you'll often see tutorials install the Docker Compose plugin. Now on Ubuntu 2.26.04, the package has been renamed. So instead of the Docker Compose plugin, we have the Docker Compose version 2. So the command you will still use in the Docker Compose app, but the package name has changed. So let's be careful when you're on Ubuntu 26.04 and upwards. So what I'm going to do now is to update my package list and then try and install Docker Compose using a different package name. Okay, so let's go over it once again. I do sudo apt update. All right, so this shouldn't take a lot of time. And then I'm going to now install my Docker Compose plugin or package. I'm going to do sudo apt install. Then the package name becomes Docker Compose version 2. And then I'll do -y. So let's try this out. Let's see. Enter. Okay, so I think this is working as expected. All right, so now I can verify if Docker Compose has been installed successfully on my server. So I'm just going to do Docker Compose version. Let me clear the screen so it doesn't cut out. So you have cleared my screen. I'm going to do Docker Compose. No, I need to add my sudo. So let's do sudo Docker Compose and then the version here. Click on enter. All right, so now I have Docker Compose version 2.40 on Ubuntu. Okay, so now let's try it out. So what were we trying to achieve? When I do ls, I have my docker compose.yml file. Now I want to use this Docker Compose file to start up my container instead of running docker run -d and then port number. I want to start all my container using just one command. So what in essence, if I had multiple services defined in my compose or my YAML file, when I run just one command, it's going to start all the containerized application just using one command. Okay, so the command I'm going to use would be docker compose app. So I'm just going to bring my sudo. So do sudo docker compose app and then run it in a detached mode -d. Okay, so let's click on enter here. Okay, so I'm going to it's building my image. Remember that we've already built that image using a Docker file, so it's using the cache image so that they can start the application well for me. And now what it is doing is that it says that, well, I've created a network. Remember, you need a Docker network if you have you need the network if you have a lot of containerized application and then they need to talk to each other. So a network has been created for me, an application has been built, and then I have my container that's Node.js app ready. Okay, so let me verify the status of this application. I'm going to do docker. Let's do sudo docker ps here. Right. So now you see that the application was started 37 seconds ago, and the container name or the name, yeah, the container name is Node.js app running. Now that I have my container running, it means that my Node.js application should also run when I open the browser. So I'm going to go to my browser, then look at my IP address, and then because you already have a load balancing, Nginx, we set up Nginx as a reverse proxy. I don't need to specify any port number, right? So I reload this, and then I have my hello from Docker. Okay, so my application is running and I was able to start this application using Docker Compose instead of the long command. So if I had multiple services defined in my YAML file, that docker compose command will start up all my containerized application. Now, one useful docker compose command is the docker compose log. That's help you to show your application logs. That's what's happening inside your application. And this is very useful when you want to troubleshoot. So when something is wrong and you want to see where exactly the issue is. Okay, so we can come here, just do clear our screen, and then just do docker compose and then logs. I want to see what's inside the application. Remember, I need to bring my sudo. So I go to end, click on enter. Okay, so now everything is, my app is healthy. It's running on port 3000. Now the question is, how do I stop this application? Remember that we set up we start our application using Docker Compose, and so to stop the application, there is a command called docker compose down. Okay, that will go to stop every running container in our server. Currently, we just have one container running. That is why when you do sudo docker ps here, we only have one container with the name Node.js app. Okay, if you had multiple services that have been containerized, you should see all their container names and then their status. Okay, so now if one wanted to stop everything, assuming we had multiple services running, then what I just need to do is to do the command sudo docker compose down. Okay, now we only have one container that is running. So I'll do sudo docker compose down, click on enter, and then I'm going to stop my application, my containerized application. So you see container Node.js app, which is the name of the container, and it's stopping now. It has been removed. If I do docker sudo docker ps here, I don't have my containerized application running again. And if I go back to my browser and reload, it should be off. So I still get bad gateway. Why? Because I've stopped my application from running. So what are we learning? In essence, we can use one command to start every service that we've defined in our YAML file. What is that command? Docker compose app -d. And we can also use one command to stop everything that we've defined in our YAML file. And that command is docker compose down. So now that you know how to use Docker Compose to start your application and also to stop your application, let's look at why DevOps engineers love Docker Compose. Now, Docker Compose makes application easier to deploy just using one command. It also makes application easier to maintain and easier to share with teammates. So instead of sending someone maybe 5 Docker commands to run 5 containerized application, or to start 5 containerized application, you simply give them your YAML file, docker compose.yml, then they run one command, which is docker compose app in the detached mode, and everything works. That is why Docker Compose is widely used in development environment and small production deployment. Now, in today's video, we've learned what Docker Compose is, why it exists, and how to write a docker compose.yml file, how to start applications using Docker Compose app, how to stop applications using Docker Compose down, and then how to view logs. That is when there is an issue that you need to troubleshoot. In the next video, we'll make this project even better by adding Nginx as another service inside Docker Compose, so the entire application stack can be started with a single command. If you enjoyed this video, don't forget to like, subscribe, and leave a comment with the next DevOps topics you like to see. Thanks for watching, and I'll see you in the next video.